we're going to introduce to you one of the most powerful, or a very powerful concept in math. And it's this idea of change, how things change given a period of time or distance or whatever it might be, because that's of interest to us. So to help unpack this a little bit, how we describe rate of change at this point in time is using the word slope. And slope in a lot of our graphs is going to be determined by how quickly something rises. Its steepness is how we're going to observe most of these. So let's give you a broad definition of what slope looks like and how we determine what the slope is. So imagine with me that I have a coordinate axis plane here, and I have some graph, some linear equation that I have graphed on that. And I have two random points that I've chosen. Basically, I want to know from this point to the next point, how quickly does it rise over its period of how far it runs. So we use this idea called slope to represent its change in its y values divided by its change in its x values. Basically, its rise divided by its run. And how we mathematically explain that is we describe both of these points here. So this distance right here is a distance of x2 minus x1. If this is my x value here, and here's another x value there, that distance is just the difference between the two of them. And likewise, its height difference, we describe that as height is the second variable, it's y variable, so I have a y2 minus a y1. And so that just helps me, or not just helps me, that describes the difference in height, or the difference in the rise. So if I take those two ideas, put this in rise over run, then I have an equation that's starting to form, but it basically says my rise is the difference in my y variables over my run, which is my difference in my x variables. And there we have what we're going to use as the definition or the mathematical expression of a slope. And we'll use some examples coming on up to help break that down and help it to make sense.